let's talk about implicit differentiation. Implicit differentiation happens when you have a implicit relationship between x's and y's, or between your variables. So an explicit function is something like y equals f of x, where you're given an input and you're explicitly told what to do with it by what the function says to do. Okay, so you're explicitly told how to get to the output when you're given an input. An implicit function is something that's a relationship between x's and y's, not necessarily exactly how to get to y given an x. There's still a little bit of work to do. Something like, say, x squared plus y squared equals 1. Right? This is an implicit function. And if you remember from algebra, you might not even tell me that this is a function, but we still think of it as a function, and it's an implicit function, and you can break it down into functional pieces to get the entire thing. Right? You can break this down into y equals square root of 1 minus x squared, and you get the other half of it is y equals minus square root of 1 minus x squared. So I can get this entire relationship from two explicit functions. And there's some big theorems in math which says that you can always do that if you have something like this. You can always break it down into explicit parts. And so these are called implicit functions. But say I do have x squared plus y squared equals 1, and I know that the graph of that from any of my algebra classes is a circle. Let's say I have this point here at the square root of 3 over 2 comma 1 half. And I want to know what's the slope of the tangent line there at that point. Well, we could break it down into one of these, and it's going to be the plus 1 because it's above the x-axis, and I could take the derivative of this and apply it at the square root of 3 over 2 to get the slope. But that's a lot of work, and sometimes I might not even be able to solve this relationship between x and y for y very easily at all. And so we can find this in other ways, and that's this implicit differentiation technique. So I'm going to think of y as a function of x in the sense that maybe I could solve it, and then we're going to do differentiation using the chain rule and solve for dy dx. Okay, so I write down x squared plus, I write down y of x, because I'm thinking of y as a function of x, squared equals 1. Okay. So I've got this expression now. It sort of is a relationship between x's and y's, where I think of y as a function of x, and now I can take the derivative with respect to x. So with respect to x, x squared becomes 2x. This is a chain rule function, so I take 2 times the inside function times the derivative of the inside function, and the derivative of 1 is 0. So I take the derivative of all the parts, and now I wanted the derivative, so I'm going to solve for the derivative in terms of the x's and y's. Okay, I'm going to get rid of the of x's now because carrying around those parenthesis x's is a little cumbersome. So we're going to streamline things just a little bit. 2x plus 2y y prime equals 0. We're going to solve for y prime. Means I move the 2x over to the other side. 2y y prime equals minus 2x. Divide by 2y on both sides. Y prime equals negative 2x over 2y. So that's minus x over y. Okay, so there's my derivative. This is dy dx. Okay. Now I wanted to know the derivative at the square root of 3 over 2 comma 1 half. So I'm going to replace all the x's here with the square root of 3 over 2, the y's with 1 half. And so at square root of 3 over 2 comma 1 half, y prime equals square root of 3 over 2 with a minus sign and 1 half in the denominator, which is the negative square root of 3. Okay, so there is the slope of that tangent line. Okay, so let's see another one. Let's try x squared y plus x squared y squared plus xy cubed equals 2xy. I've got lots of product rules going on. Here's a product of two functions, a product of two functions, a product of two functions, a product of two functions. So I'm going to do product rule several times here. And I get different things to worry about for each of the first part and the last part of the products. So the product rule says derivative of first times second plus second times derivative of the first. So the derivative of the first is 2x times the second plus the first times the derivative of the second. So derivative of y is y prime. Okay, we get to do that again with this one. So I've got the derivative of the first, 2x, times the second, y squared, plus the first, x squared, times the derivative of the second, that's 2y, times y prime. Remember, y is a function of x, so the y is always an inside function. Anytime you take a derivative, you're going to have to multiply by y prime. If you took a derivative of y, you have to multiply by y prime. Let's do it again. I've got the derivative of the first, which is 1, times the second, plus the first times the derivative of the second, so 3y squared y prime again. Okay, so I took the derivative of y, I have to multiply by y prime. That's a prime, okay? And then equals, I've got a derivative of the first is a 2, and I've got a y, plus the first, 2x, times this y prime, derivative of the second. Okay, so I've got y primes here, I've got a y prime here, got a y prime here, I've got a y prime here. I don't have a y prime, I don't have a y prime, I don't have a y prime, and I don't have a y prime. I want to get y prime by itself, so I'm going to move all the y primes to one side, factor out the y prime, move everything else to the other side, and then to get y prime by itself, I'll divide. Okay. So let's move all the y primes to the left, because there's more of them over here on the left already. So I've got y prime, and I've got a y prime times an x squared. I've got a y prime times a 2x squared y. That's that one. Now for this one, I've got a y prime, and I've got a 3x y squared. And then this one, when I move it over, becomes a minus 2x. Yeah? Okay, let's move all the blue stuff over to the right-hand side. This is already over here, so we're going to start with that. That's a 2y, it's positive. And then I have to subtract all the other things. I've got a 2xy. I've got a minus 2xy squared. And I've got a minus y cubed. Those are the things that don't have a y prime next to them. So to get y prime by itself, I'm going to divide everything by that stuff I just underlined. So I get 2y minus 2xy minus 2xy squared minus y cubed. We'll divide that all by x squared plus 2x squared y plus 3xy squared minus 2x. And that is what y prime is. Okay, let's see one more. Let's look at, say, y squared equals x minus 1 over x plus y. Okay, I could use a quotient rule, but the quotient rule is something I don't like to do because it squares things and it makes things more complicated. So what I'm going to do instead is I'm going to clear out denominators, and just like with other implicitly defined functions, remember, if we simplify first, it usually makes things easier to take derivatives of. So instead of taking the derivative of that, the same function is y squared times x plus y equals x minus 1. Okay, the only thing that I have to sort of remember and carry around is that x does not equal negative y. Here, I don't want to divide by 0, so I have to remember, like in the domain, I don't want that to happen. Okay, and that's the last I'm going to say about it, because that doesn't really come up too often, at least not in this level of math. Okay, in higher levels of math, we might have to carry that around and keep that in the back of our head to remember that, okay, what is our actual domain? Make sure we're not screwing up by dividing by 0. Okay, as long as we're not dividing by 0, we can do this. Now I'm going to distribute again, so I got y squared with an x on it, and y cubed equals an x minus 1. Okay, we could do the quotient rule, but I think it's easier to do this, so we're going to take the derivative of this. I get x times 2y prime plus 1 times y squared. That's the product rule on the first one. Plus, this is just a chain rule, 3y squared y prime equals 1, because the derivative of x is 1, derivative of minus 1 is 0. Okay. Sometimes these primes, they look like exponents of 1, so make sure that you're careful with how you're making your notation so that you actually know when you have an exponent of 1 or if you have a prime there. Okay, we're going to get the y primes by themselves by factoring out y prime and collecting them on the left. So I've got y prime and I've got 2xy, and I've got a y prime and I've got a 3y squared. Okay, the other stuff. On this side of the equation I have a 1, and I'm going to move this over, so I've got a minus y squared. So y prime is equal to 1 minus y squared over 2xy plus 3y squared. There's my derivative. Okay, let's do another one where I find this thing at a specific point, say. Let's find the derivative of let's go x squared plus xy minus y squared equals 1 at 2, 3. Okay, I should make sure that this point 2, 3 is on this curve. So if I plug in 2, 3 to check the points on the curve, I'm going to plug in the x's and the y's and make sure that I have a true statement here. So I plug in 2 squared plus 2 times 3 minus 3 squared equals 1, and I check and see if that's true. If that's true, I've got 4 plus 6 is 10, 10 minus 9 is 1, so that checks out. So this point is actually on this curve. That's good. Now I'm going to find the derivative, plug in the 2's and 3's, and then figure out what the derivative is. Okay, so 2x is the derivative of x squared with respect to x, plus I've got a product, so I have to use a product rule, x y prime plus y, 1 times y, minus 2y y prime equals 0. Okay, I could isolate y prime and solve this and divide and do all that algebra, but I'm just asked to find this at 2, 3. So instead of doing the algebra and carrying around the x's and the y's, I'm going to put in the numbers, and then I can just do arithmetic and solve for y prime in a linear function, which is going to be really nice for us. So 2x is 4. Then I've got the 2y prime plus 3 minus, that's going to be a 6 y prime equals 0. Okay, and then this is just a 101 problem, algebra 101, right? Okay, so I've got 7 minus 4y prime equals 0, so y prime equals 7/4. There's my slope at 2, 3. Okay. We could do the arithmetic, the algebra here, get y prime, and then put this stuff in, but why not do it right away? Okay, let's find a second derivative. That's the last type of thing that we need that's sort of new. So let's find a second derivative of, say, y cubed plus y squared minus xy at that's not the problem. Sorry. Y cubed plus x cubed equals 16 at 2, 2. Okay, find d squared y dx squared. Find the second derivative at 2, 2. Okay, so we're going to find the first derivative first. And so I've got 3y squared y prime plus 3x squared equals 0. Okay, and I can solve for y prime to get the first derivative. And I actually have to do the algebra here. I can't plug in the number. I could get the value of the first derivative, but I can't get the first derivative as a function. And I need the first derivative as a function to be able to find the second derivative. So I have to solve for y prime here. Y prime is equal to minus 3x squared over 3y squared here. So that's minus x squared over y squared. And now I want to take the second derivative of this. Okay, so now I have to use the quotient rule. I can't just avoid the quotient rule because I've got this y prime stuff. So I get that y double prime is equal to the quotient rule, low, times the derivative of the top, minus 2x, minus the derivative of the minus the top, minus x squared, times the derivative of the bottom, 2y, y prime, right? And then we're going to divide by the bottom squared, so that's going to be y to the fourth is what we're going to divide by. Okay, so here at 2, 2, this is going to be a minus 1 at 2, 2. And so I can put in y prime at 2, 2 equals a minus 1. So y double prime equals, I got 2 squared times minus 2 times 2 minus a minus 2 squared times 2 times 2 times minus 1, from the y prime being minus 1 divided by 2 to the fourth. Okay, so what do I've got here? I've got a minus 16, and I've got another value of 16 with a 1, 2, 3 minus sign, so another minus 16. That's going to be divided by 16, so that's going to be minus 2 is what my second derivative at 2, 2 is. First derivative is minus 1, second derivative is minus 2. Okay, so be careful when you're doing this stuff. Remember, to take a second derivative, you have to have a function to take a derivative of, right? So you can't evaluate first, and so on. Okay, that's implicit differentiation, and I will see you guys in class tomorrow.